Okay, so right now we have all of our analysis settings set up. We're going to select, we want it to analyze true wind speed and true wind direction, and we're not so worried about barometric pressure in this instance. Our analysis mode is the all GRIB runs, and that means model accuracy will take the freshest GRIB file data compared to log file data. So if I'm getting GRIBs every 12 hours, at the new part of that 12 hours, it's going to review that GRIB file data. If I'm getting GRIBs every 6 hours, I'm never going to be comparing GRIB data older than 6 hours against the log file data. So we'll go with the all GRIB runs, and we're going to select plots, and then we're also going to select save. And that's going to save all of our statistical analysis and our graphical plots into the directory labeled tutorial video, which can be accessed by clicking the view button. So we're going to go ahead and analyze, and we're going to see that model accuracy is comparing the coamps, and it's going to start generating those reports right here. And then it's also going to compare the GFS and the NavGem and the NDFD. And it's doing that just for true wind speed and true wind direction. And you can see graphs are starting to show up here. And we have that graphical analysis as well. So now we're going to go through what each graph means. So for true wind speed, the boat data is the black line. This is what was actually captured on the boat instruments for true wind speed. We started out around 11, we peaked around 20, the true wind speed went way down, went way back up to 20 knots, and then had overall trends. The coamps data in GFS and NavGem and NDFD are all color-coded on what the GRIB file thought was going to be happening at that lat long in the middle of the ocean. And then this analysis is compared. The new GRIB file data is represented by the red square, and the time step data is represented by the green circle. So you can see here, in this instance, we got a new set of GRIB data every 12 hours. And we had GRIB steps sometimes about every 3 hours, depending on that individual GRIB file. Really, really handy to view. Now the true wind direction data is projected on a scroll. So imagine this as a complete scroll of paper that would be going over. So again, the black data is for the boat. What the boat was logging as true wind direction magnetic due to our selections. And this is the plot of the GRIB file data compared to the boat's wind instruments in its color-coded GRIB files. And you can see that sometimes we were to the right of what the truth was, the boat data being the truth, and over here we were to the right of the boat data, and then sometimes the forecast file was to the left. But overall, the forecast files did a pretty good job of matching the trend of what the true wind direction actually became. And model accuracy highly, highly rewards GRIB files that get the trend correct. But nobody got this big. This must have been some sort of frontal passage right here, or some sort of micro cloud that was just not in a GRIB file. And then we'll go down to the actual analysis. So let's expand up to our analysis, and we'll see the final data that model accuracy is telling us. So in the coamps, it's telling us, we can see our analysis start time, February 26th at 12Z, and we went to March 1st at 19Z for a 1 minute granularity. And our true wind speed correlation, the trend correlation, meaning the forecast got the trend correct with what actually happened on the water 80% of the time, and had an RMS error of 4.5 and an average error of 3.2 knots above the log file data for true wind speed. And to calibrate that into our optimal routing, we would bring down the coamps GRIB file 3.2 knots. The true wind direction got its correlation right only 28% of the time, and its RMS error was much higher. Now don't let that throw you off, because you can see how most of the RMS error for the true wind direction is in the 40s, because the true wind direction is 0 through 360, whereas true wind speed is generally 0 through around 30 knots. So it's a much bigger range for true wind direction, just because it's a much bigger range of numbers for 360 degrees. the average air in the true wind direction was 13 degrees right of the log data. So this means that COAMPS was saying that the wind was going to be 13.9 degrees right of what the boat on average saw on the water. So to calibrate that in your optimal output, in your optimal routing, where you can actually twist a GRIB file, you would calibrate it minus 13.9 degrees. Our model accuracy error is a trade secret of how we evaluate that, but that it's the one single number of how good a GRIB file is. You want a low error number. So we're 5.66 for COAMPS, GFS is 5.0, NavGen was 5.36, and then the NDFD was the worst. So from this analysis data, model accuracy had the best score for 5.0, which is the GFS. Scrolling down here, you can see a little bit more of where your directory was. These are the settings that you had when you clicked Analyze, what kind of analysis mode. We did the all GRIB mode. We did no data smoothing. That's the masthead height, and that will all be there in your view file. So we'll click out of this, and we'll click View, and this is where all those datas are. The true wind direction, the true wind speed, and your GRIB analysis. That is a summary of your model accuracy analysis settings and optimal outputs.